Picture this. You're 12 and your parents have decided to take the family on a summer vacation to an amusement park. You get there and you see your first roller coaster. It's huge and you're wondering how on earth that thing can even function. How is that beast of a machine not breaking because the cars are moving so fast? How is it even sitting on the ground without the ground cracking underneath it? Well, to understand that, we need to go all the way back to the early 1800s to the creation of the railroad. You may be wondering how the railroad could be anything like a roller coaster. How could they be connected? Well, as it turns out, they're actually very similar. They both have tracks and cars, both require supports in the ground, and both are extremely heavy and generate a lot of force. So to understand the foundation of a roller coaster, we need to first understand the foundation of a train. The basic structure of a railroad system consists of the train and its cars, the tracks and its support ties and sleepers, and the track foundations. The whole system is fairly simple, but complications arise due to the weight of the system. Some of the heaviest trains can weigh up to 18,000 tons. This weight alone is the same as approximately 128 blue whales or around 180 space shuttles. This is a lot of force and vibrations to put on the ground. These kinds of forces can cause compaction and settling on the subgrade beneath it, which could cause a height change for the tracks, which could damage them and possibly cause the derailment of the train. None of this is good, so this is where an engineered subgrade comes in. Train tracks are typically laid out on and attached to a material known as ballast. Ballast can be made from many different materials, but it's commonly made from crushed rock, washed gravel, and/or slag. The purpose of the ballast is to bear the load of the tracks. The shape of the ballast pieces allow for them to interlock after they've been compacted, so they act like one large piece of material under the tracks rather than a bunch of small pieces. Here are a couple videos displaying the difference between a solid foundation and a looser foundation. They show how a moving vehicle exerting a force on supports might affect the underlying foundation. The supports in these videos are similar to that of roller coaster supports. The first video shows a vehicle on top of a solid foundation, like how ballast pieces interlock, or on a material similar to concrete. And the second video shows how the vehicle would affect the supports on a foundation such as gravel or soil. In the first clip, the foundation and supports were both solid under the force of the vehicle. In the second clip, the foundation under the supports shifted, causing the supports to fail. Even though ballast tracks serve as a fairly solid foundation, they aren't the only foundations being used today. Many countries use ballastless foundations. This type of track replaces the ballast with something like concrete. The concrete can give a much smoother ride and results in less vibrations. Concrete is an extremely useful material for large-scale projects because of its impressive capability to resist compressive forces. This brings us back to roller coasters. With the development of trains being such a success, it's likely that roller coaster engineers were inspired by the foundations of trains because of their ability to handle such large machinery. We can see the similarity in the design through the entirety of the roller coaster. What we're focusing on, however, are the foundations. Roller coaster foundations are made from reinforced concrete. What is that? Reinforced concrete is a hybrid of concrete and steel. Steel bars are inserted into the concrete molds before the concrete sets. Well, why isn't it just concrete like the train if they're so similar? Normally, just concrete would be fine if it weren't for the high speeds and sharp dips and turns commonly found on roller coaster rides. One downfall of using concrete is that it's very weak when a tensile force is applied. This would create large issues with the coasters because they're constantly applying both compression and tension. When the cars race at a downwards angle on the tracks, compression is applied. When the cars race in an upward direction, tension is applied on the supports below. Concrete can't handle all that stress, so adding steel supports aid in the resistance of that force, as well as adds a bit of flexibility to the foundation. Now that you have some basic understanding of how subgrade plays a role in the construction of heavy machinery, your inner 12-year-old can rest easy knowing they're safe to ride that roller coaster.